Hello everyone, today we are here to talk to you about our study which is on the full-scale implementation of reduced temperature 1 mix asphalt in Oklahoma. As we all know, climate change has been causing a lot of disasters in our world today, and emissions from the construction sector has actually been found to be one of the main drivers of climate change. So in the asphalt pavement industry, the usage of reduced temperature 1 mix asphalt has actually been found to be one of the ways where we can reduce our emissions. But the lack of well-documented demonstration of the use of WMA in real life has been one of the major challenges to WMA's adoption. And that is why in this study, we were aimed at demonstrating that WMA can actually be produced and paved at reduced production temperature. Also in this study, we wanted to compare HMA to WMA based on different metrics, based on fuel consumption, the rate of temperature loss, mix compactability, and stack emissions. During this field study, we produced more than 3,000 tons of HMA and WMA. And my colleague Bibek will give you more details about the data collection.
Okay, so during the field implementation of 1 mix asphalt in short WMA, our main goal was to measure the temperature of asphalt mix at different stages of production. We use infrared sensors to measure temperature during production, loading, unloading, and throughout paving and compaction. As we can see from this graph, WMA production temperatures were consistently lower than the hot mix asphalt, in short HMA. Furthermore, this heat map shows the temperature across the width of the pavement, and we can notice that on WMA day, the pavement temperature was lower than on HMA day. The same pattern can be seen during compaction as well. Besides temperature measurements, we also collected weather data and monitored emissions like particulate matter and volatile compounds. We also collected asphalt mix and aggregate samples for lab testing. The preliminary analysis shows that the average temperature difference during production between HMA and WMA was about 50 degrees Fahrenheit. Also, temperature drops can be seen in both mixes at later stages. However, the rate of drop is faster in case of HMA. I would like to mention that previously we quantified the environmental impact of HMA and WMA in the lab, and the result shows that WMA has a lower environmental impact. In summary, I would like to say that the asphalt can be produced at lower temperature, which reduces the fuel consumption and eventually reduces the environmental impact. Moving forward, we will be analyzing fuel consumption and emissions data, and we will also be conducting a cradle to grave life cycle assessment. We want to give a special thanks to J. Lemon and Haskell Lemon construction team for allowing us to implement this 1 mix design at the plant. We are also grateful to Ingenuity for providing the additives and pumps, Highway Data Systems for setting up the temperature instrumentation, and Montrose for recording environmental emissions. We are also thankful to ODOT and the Federal Highway Administration for sponsoring this project. Thank you very much.